right. Well, welcome to Navigating Patterns. I notice I have a bunch new subscribers thanks to Mature Peugeot and his wonderful endorsement of my channel. I'm sort of shocked and humbled by this wonderful event. One thing I've been trying to talk about for a while is scaling, and I think I figured out a way to do that. So today we're going to discuss the issue of scaling. Now, scaling is a big issue in a lot of areas. We have a solution to a problem. Say, I know how to fix this for myself. How does that scale, right? And I think a lot of people don't understand what scaling is and what it means and how it works. And there are reasons for this. I think a lot of it has to do with scientific thinking, which sort of leads us to believe that relationships are linear somehow and that they're sort of one-to-one and they're discrete. And it's like if you move this an inch, then that moves an inch, or move some ratio to an inch. And that's true in certain domains, for sure. There's a lot of the world that works that way. But scaling is, I think, when that changes. So the world seems to be laid out such that there's linearity and then there's this non-linearity that happens outside of some domain. And a sort of one area that this occurs in is random numbers. So a lot of people don't know this. Nassim Taleb sort of talks about this, but a lot of the mathematical rules change based on the set size. So how big a set of numbers you're dealing with, not in terms of the number of numbers, but the range of numbers. So for example, if you extend the range of numbers high enough, randomness creates order. In other words, randomness doesn't function as randomness anymore. And that's a function of scale. So when you scale up to a certain number, I don't know off the top of my head what the numbers were. I know they proved this mathematically, which is sort of ironic. Randomness breaks down and creates order instead of disorder. And it's a huge range. But that's kind of interesting, right? And then there are also systems, because another aspect of scaling is actual detail. There are systems where once you have so much randomness, adding more randomness actually decreases the entropy and creates more order. It's two different ways, right, that randomness doesn't function correctly anymore, and it's past a certain point or boundary. Another way to think about scaling is not just by size, because those are size examples, right? Either amount in the bucket, we'll say, or size of the bucket. Sure, fair enough. That changes the nature, right? And the change in nature where it stops being linear is the scale. It's a scaling, change in scale. Another way that scale changes is, let's suppose that you run into somebody on the street and you want to explain something to them, and they are a stranger. The tools that you have available to you that you can use are limited. Now, let's suppose, and that's one person, right? Let's suppose you're talking to a friend of yours that you've known for years and you have a lot of detail about their life. The tools that you can use are much greater, like you have a much bigger toolbox, right? And so that's another way to think about scale as a function of detail, right? And the way you see this is, let's suppose, for example, that I'm in a room with a bunch of scientists. And because I'm in a room with a bunch of scientists, I can make a bunch of statements and they will understand that basic science. Now, let's suppose I'm in a room with a bunch of physicists, right? The explanation that I can give about physics is much more detailed and greater, right? And so I can use fewer words to explain a very complex topic because the assumptions are all the same, right? The base knowledge is not all the same, but really close in most cases. And so that explanation doesn't scale outside of that expertise level, right? People without that much detail can't use that simplified explanation and understand it because there's all this base assumption built in. It's another way that scale functions. And I think the real problem with scale is not that it's a function of size, or it's a function of amount, or it's a function of amount plus size, or it's a function of amount plus size plus detail. Lots of things break at scale all at once along different axes. And we don't like this, right? We're used to the scientific reductionist view of the world where scale is just a linear function, and as you add things, you can add other things to compensate for the adding of things, and it all just works out. But really, and Jordan Peterson does a good job pointing this out, right? There's this Pareto distribution. And if you really want to learn about the Pareto distribution, Peterson found out about it late. Taleb was talking about it all along, I think, in Fooled by Randomness, which was one of his early books there. The Pareto distribution, this Cauchy curve is the technical term. I don't want to get too data sciencey on you because I actually do know the data science and learned all the statistics from Taleb and a few other books, right? It changes the nature of how things actually function, like where the scaling points are, right? So the point of scale is basically when the linearity changes, and now all of a sudden a bunch of things change all at once. And so we operate on this Gaussian curve, which is a very soft curve. We fit everything to the Gaussian curve. Why, I don't know. It doesn't fit nature. A Cauchy curve is very close. It's a sharper curve. It's very close to nature, though. It's not exact, but it's much better than the Gaussian curve. And Nassim Taleb is the one that really talks about this in a way that you can really understand without math. He has some of the math. You can engage with his math papers, or you can just read the book or the books and understand his point through narrative. He's very good with that. Actually, he's probably the best I've ever read for that. Scaling is the thing that changes when you get near the edges of those curves, right? And then the level of change is non-linear, or usually it's referred to as logarithmic. I don't know that it's actually logarithmic. I can't follow the math on Taleb stuff because I'm not a math guy. Ironically, that's what computers are for. They do the math. I don't need to. That is what scaling is about. So you're not just changing the number of items you're dealing with. You're not just changing the amounts you're dealing with. You're not just changing the number of items you're dealing with and the size, right? You're also changing the detail level at which you're operating. And so again, if you want to explain something, say, scientific to a crowd of curious readers, that's called popular science. The pop sci explanation of something is usually so, quote, low resolution, to borrow from Jordan Peterson there, that when people try to apply it, they can't, right? And that's because in order to generalize it enough for a large audience of people you don't know, who don't have the same base level of knowledge about science, you have to water it down. So if you want to scale it, it has to lose detail, right? So you can see the functioning of detail in scale. And it just seems to be, if you want to put it this way, an iron law of the universe, or the way nature functions. One might refer to that as reality, that these trade-offs are inevitable. And so I have a video about an I answer to a we question. It's a great video. You should check it out if you haven't seen it yet, where I point out that a lot of times people are giving answers that worked for them personally in their personal circumstance, and either giving that as advice to everybody, or saying, hey, this worked for me, and therefore, or they're trying to scale that to larger audiences. And the problem is, it doesn't scale to larger audiences. And so you need to be aware of that, because that's actually important to know. And so that's my bit on scaling. Scaling is this breaking out of the box. It's where things stop being linear. That's where the scaling points are. If they're still linear, you haven't broken scale yet. And look, the reason why I understand this well enough to even try to talk about it, however poorly I may be doing, is because I've done it in computers, like for my whole life. When you write software for just your use, you cut a lot of corners. It doesn't make any difference. when you try to write software, for 10 of your friends to use individually, maybe you make a few modifications. When you want to write software for strangers to use, you have to rewrite all the code. It just is what it is. There are, again, reasons for that, and you find out if you actually write software and start, expanding out the audience of the software. But I think that's everything, and I think that's part of reality. I think it's part of the trade-offs that happen as a result of the constraints of the creation we were born into. Like, I don't think it's optional. I don't think you're going to find a magical science boson particle or boson derivative to solve it. Like, I don't think that's the way it works. And understanding that scaling is an issue is important, because if you understand that maybe the trade-off for having to give a lot of detail to people who maybe can't hold that detail just mentally, because people have cognitive limits, is charisma. Maybe charisma is not optional in the world, right? Maybe the trade-off for explaining something well enough to somebody to convince them is knowing enough detail about their life, right? Which requires spending enough time with them over time to be able to convince them through rational means. Maybe that has to be personalized. And then maybe those are the, say, two ends of the spectrum, right? And the difference is in the telos, right? And I have a live stream on telos. You should check it out. It's rather good. If they're doing it for the good, it doesn't matter what method they're using. Like, if I enchant you with charisma or a good story, like a narrative, so-called narrative, although I have a video on story, narrative, and archetype that you might want to check out. If I'm doing it for the good, what difference does a mechanism make, right? On the other hand, right, if I'm just using the mechanism or using multiple mechanisms, but I'm a bad actor, it doesn't matter what the mechanism is. It makes no difference. And that's part of what John Vervaeke refers to as relevance realization, in my opinion. What's relevant? Goodness is relevant. Truth is relevant. Or the true is relevant. And beauty is relevant. And what else is relevant? I'm going to go with nothing. I think those are the relevant things to look at. And when you pay attention to them, the issue of scaling becomes clear, because now you can say, well, where is the scaling point, or where are the scaling points? And what does that mean for the message I'm trying to send or the thing I'm trying to do, right? So, for example, it might be at the political level, at a country level, right, that you have to rely more on charisma to get the people to do the good thing than you can rely on convincing them through a rational argument. That might be one reason why politics looks the way it does. Now, I'm not going to flat out make that claim. I'm just going to say, maybe consider that and observe the world for a bit and tell me what you think. And by the way, if you have topics or questions or interaction of any kind, always welcome interaction. Hopefully I can keep up with it all. Comments down below, click the like button. If you get any friends who need to hear this, tell them to subscribe. Getting close to monetization status here somehow, rather suddenly, a little bit overwhelming. But I'm very happy that I can get more attention to the channel, because I think I do a reasonably good job with trying to explain things in a way that is helpful to people that they can use, rather than just throwing out random terms and saying, you know what I mean? You get it, right? And that's really a function of the audience interaction and participation, because when you pay attention to what I'm trying to say, you can help adjust my message. And I always appreciate that thing that I definitely value the most, which is your time and attention.